All right, if you're a systems programmer, you've probably spent countless hours just wrestling with memory. But what if I told you there's a powerful, almost secret technique that pretty much challenges the way we're all taught to code? We're about to dive into a memory management pattern that could fundamentally change how we write fast, reliable software. So let's kick things off with this quote from game developer Ryan Fleury. It's a joke, obviously, but it's one of those jokes that's got a really serious point. It hints that the standard tools we all lean on, like malloc, might be hiding a much simpler, more powerful way to think about memory. And that really brings us to the maze that every C, C++, or any low-level programmer has gotten lost in at some point: manual memory management. It's kind of a rite of passage, but let's be honest, it's also the source of so many headaches. See, we're given this amazing promise of infinite flexible memory. Need a few bytes? Just call malloc. Done with them? Call free. Sounds simple, right? But the reality, as we all know too well, is a total battlefield of memory leaks, use after free bugs, fragmentation, and those performance stutters that you can just never seem to track down. Now, what's really going on here? Why is malloc so tricky? Well, it's because it's solving an incredibly difficult, very generic problem. It has to be ready to handle allocations of any size, with any lifetime, coming from any thread, at any time. That complexity, it leads to thread contention, it absolutely kills performance in critical hot loops, and it ends up chopping our memory into these tiny, unusable little pieces. But what if a better model was right under our noses the whole time, hiding in one of the very first concepts we ever learned in computer science? Let's just reconsider the function call stack for a second. We usually just think of it as a language feature, something the compiler handles for us. But what if we looked at it as a design pattern? Because it is, in its own way, a perfect and beautifully simple memory manager. Think about it. When you call a function, its local variables get pushed onto the stack. When the function returns, they're all popped off in one single instantaneous operation. Bam! The lifetimes of all those variables are perfectly grouped together. There are no leaks, no free calls to forget. It's ridiculously fast and simple. And this is the million-dollar question. The stack is amazing, but it's rigidly tied to the function call hierarchy. We can't allocate something in a function and expect it to live on after that function returns. So how can we get that beautiful, simple stack-like behavior for more complex, dynamic lifetimes? Well, that brings us to a really powerful concept used by high-performance developers everywhere: the arena allocator. An arena is basically a stack that you control. Instead of the compiler managing it, you do. You just grab a big chunk of memory, and to allocate, you just bump a pointer forward. That's it. It completely decouples that beautiful stack allocation pattern from the rigid lifetime of a function call. The lifecycle is just so straightforward. First, you reserve one large block of memory from the OS, maybe a couple of megabytes. Then, as your code needs memory, you just push, advancing a pointer each time. And the best part is the cleanup. You don't free individual little pieces. You just reset the pointer right back to the beginning, clearing the entire arena in a single, trivial operation. Okay, so this radical simplicity, it's not just elegant, it unlocks some absolutely incredible performance superpowers in real-world applications. In the common case, an allocation from an arena is just a pointer increment and maybe a bounds check. Sound familiar? That's basically what a stack allocation is under the hood. It is orders of magnitude faster than a typical malloc call, which might have to go search complex data structures and lock mutexes. So where would you actually use this? Well, in game development, where every single nanosecond counts, arenas are a total secret weapon. A classic pattern is the per-frame arena. At the beginning of each frame, you just reset the arena's pointer. Then, for the next 16 milliseconds, you push all the temporary data you need, particle effects, UI strings, whatever, right onto the arena. When the next frame starts, poof, it's all gone. This completely vaporizes that old rule of don't allocate in a hot loop. And this isn't just for games. This pattern is just as valuable in the world of high-performance web servers. It's a brilliant example of its power. Imagine for every single web request that comes in, you grab a clean arena. You parse the request, hit the database, build your JSON response, pushing all that data onto the arena. As soon as a response is sent, you just wipe the entire thing.
This gives you predictable, high-throughput performance without that infamous sawtooth memory pattern you see with garbage collectors, or the fragmentation from malloc and free. All right, I know what you're thinking. If arenas are so perfect, what's the catch? Why isn't everyone using them all the time?
Well, the big limitation is really the flip side of its simplicity. Just like a stack, you can't just pluck an item out from the middle. If you have a game level loaded into an arena and one enemy gets destroyed, you can't just free that enemy's memory, because there's other valid data sitting right after it.
But there's a simple and really elegant solution for this. You just build it yourself, right on top of the arena. When that enemy is destroyed, you don't try to free its memory. Instead, you add that memory slot to a simple linked list of available slots, a free list. The next time you need to spawn a new enemy, you just check the free list first before you go bumping the arena pointer. Now, you might be thinking, wait a minute, aren't we just re-implementing malloc? And the answer is a firm, definite no. A free list for, say, fixed-size game entities is maybe 5 lines of code. You're not solving the massive, generic, one-size-fits-all allocation problem. You're solving your very specific problem with a simple, tailored solution. Ultimately, adopting arenas isn't just about learning a new data structure. It's about a fundamental shift in how you think about memory and how you structure your programs. This mindset forces you to stop thinking about managing individual objects and instead start thinking about managing entire lifetimes, all the data for a frame or for a request or for a level load. You start passing allocators around explicitly, which makes your code so much clearer, and you simplify the whole problem. Instead of a million tiny complex malloc calls, you make maybe 10 big ones to get your arenas, and the rest is just simple, blazing fast pointer bumps. So the next time you're starting a project and thinking about memory, I'll leave you with this question. Are you going to fall back on the old patterns, asking for memory one tiny piece at a time? Or will you simplify the problem, take control of lifetimes, and enter the arena? It's an incredibly powerful pattern that can make your code simpler, faster, and way more robust.